Hi guys, welcome back. In today's session, we will understand one of the core concept in the Kubernetes, that is autoscaling. So what is autoscaling? Autoscaling is the process of increasing or decreasing our infrastructure or resources based on the demand. So for example, I'm running my application in one pod. I'm running my application in one pod. So assume that this is pod 1. Inside this pod 1, my application is running. Right. So users are accessing our application, which is running in the pod. Incoming requests are coming to our application. So there are multiple customers available who are accessing our application. When less number of users are accessing our application, one pod is going to handle all the requests and it is going to provide the response. For example, if we have some offer in our application, if they assume that there is a big billion day in our application, when there is a big billion day in our application cannot handle the load with only one pod. So currently I deployed my application in the Kubernetes cluster with one pod. So one pod means only one instance is running for our application. When less number of requests are coming for our application, then that pod is sufficient to handle the request. Suppose if more number of users are accessing our application, then that pod is not sufficient to handle all the requests. When one pod is there to handle all the requests, there is a chance of pod crash and there is a chance of application downtime. So that's why what we need to do is we need to increase our pods when more number of requests are coming. This is pod 1 and I need to go for pod 2 and I need to go for pod 3. So here, when more number of requests are coming, my pod count should be increased. When the less number of requests are coming, my pod count should be decreased. So I will go for 3 pods now. So earlier, my application is running in only one pod, less number of users are accessing. Tomorrow, as I have an offer, I'm going to increase my pod count to 3. So multiple requests will come and multiple pods will be available. In every pod, same application will run and multiple pods will process multiple requests which are coming to our application. But here, the problem is deciding how many pods are required for our application. So we don't know how many requests will come tomorrow. Tomorrow offer is there. So 1 lakh requests will come per minute, or 2 lakh requests will come per minute, or 3 lakh requests will come per minute. We don't have any clue on that because it is a future activity. So today it is running with one pod. So less number of users only accessing our application, it is able to handle the load. Tomorrow offer is available. More number of users will access our application. Currently, I'm thinking that tomorrow, as there is a big billion day offer, per minute, 1 lakh requests will come. I'm thinking that 1 lakh RPM. 1 lakh RPM will be there tomorrow. That means requests per minute. So to handle 1 lakh requests per minute, one pod is not sufficient. That's why I have increased my pod count to 3. Okay, if 1 lakh requests comes per minute, then no problem. 3 pods will handle those load. Suppose 3 lakh requests are coming per minute. If 3 lakh requests are coming per minute, 3 lakh users are accessing our application per minute, then what is the problem? I have assumed that 1 lakh requests will come per minute. To handle 1 lakh requests per minute, I'm creating 3 pods in my application. So 3 pods will handle all the 1 lakh requests which are coming to our application. So that is my guess. Suppose if 3 lakh requests comes, then 3 pods are not sufficient. Okay, then, so what I will do is assume that instead of running my application in the 3 pods, I'm going to run my application in the 6 pods. So when I run my application in the 6 pods, okay, 3 lakh requests can be handled. I have increased the pod count to 6 because 3 lakh requests are coming. For example, if we get 5 lakh requests per minute, those 6 pods also not sufficient. Again, we need to increase our pod count. From 6 pods, I'm going for 8 pods. From 6 pods, I'm increasing my count to 8 pods. So when the traffic is increasing, I have to increase my pod count. Suppose, for example, my application is having 5 lakh requests per minute. So I have configured total 8 pods to handle that load. All of a sudden, when my application is having 5 lakh requests per minute, all of a sudden, one politician met with accident, or one celebrity met with accident. Some situation happened. One celebrity met with an accident. Then what will happen? People will divert to media from the e-commerce application. Initially, in the regular days, so now in the regular days, the number of requests is only 5,000 RPM. Right. In the normal days, only 5,000 people are accessing my application per minute. To handle 5,000 requests per minute, my application is running with 1 pod. But tomorrow, there is an offer in my application. I'm expecting more number of users will access my application. For every product, 50% offer is available in my project. Okay, guys. In the normal days, 5,000 users are accessing our application per minute. To handle 5,000 requests, 1 pod is sufficient. But tomorrow, I have a offer, Big Billion Day. As there is a offer, more number of requests will come. I'm assuming that 1 lakh requests will come. Right? If 1 lakh requests are coming, 1 pod is not sufficient. I'm going for 4 pods. Suppose if I get 3 lakh requests, then I will go for 6 pods. If I get the 5 lakh requests, then I will go for 8 pods. Like that, I need to increase my pod count. Now I am running my application with 8 pods. All of a sudden, when my offer is running, one celebrity met with an accident, one politician met with an accident. Then what will happen? People will divert from shopping to news channels, media. So once this incident is happened, my requests are reduced. Now I am getting only 50,000 requests per minute. To handle 50,000 requests per minute, these many pods are not required. Now I need to reduce the pod count. When more number of requests are coming, I need to increase the pod count. When less number of requests are coming, I need to decrease the pod count. So increasing the pod count, decreasing the pod count manually is a very difficult process. Are you guys clear? By the time you increase the pods, you will lose your business. By the time you increase your pods, you will lose your business. So that's why we are going to use a concept called auto scaling concept. In the projects, we are going to use a concept called auto scaling concept. What is auto scaling? Auto scaling is a way to automatically scale up or scale down the number of computing resources that are allocated to our application based on the demand. Could you please read this? Auto scaling is the approach to automatically scale up or scale down the number of resources that are being allocated to our application based on the demand. For example, for my application, I have allocated 1 pod. Okay, currently my application is running on 1 pod. When more number of requests are coming, based on the incoming requests, my pod count should be increased. When the less number of requests are coming, my pod count should be decreased. Based on the incoming traffic, pod count should be increased. Based on the incoming traffic, pod count should be decreased. That is called auto scaling. Increasing the pod count, decreasing the pod count manually is challenging task. That's why Kubernetes provided one important feature that is called auto scaling. Auto scaling is a way to automatically scale up or scale down the number of resources that are allocated to our application based on the demand. Now you see here, when less users are accessing our application, 1 pod will be available to handle all those user requests. When more number of users are accessing our application, more pods should be created. In the Kubernetes, everything is a pod. In the Kubernetes, everything is a pod. Now here, how to implement this auto scaling? Guys, auto scaling can be done in 2 ways. So auto scaling is the process of increasing or decreasing our infrastructure or resources based on the demand. Auto scaling can be done in 2 ways. One is horizontal scaling and the next one is vertical scaling. So when you go for auto scaling concept in the AWS also, we are going to see this auto scaling. So auto scaling can be implemented in two ways. One is called horizontal scaling and the second one is called vertical scaling. Horizontal scaling means increasing the number of instances. Increasing the number of the instances, that is called horizontal scaling. Here, my application is running in one pod. When more number of requests are coming, when more load is coming for our application, then instead of one pod, I will increase to 3 pods. That is called horizontal scaling. Then what is vertical scaling? Vertical scaling means increasing the capacity of the single system. Now, in one system, in one worker node, my pod is running. There is a load on the worker node. When there is a load on the worker node, we want to increase the capacity of the worker node. Instead of 4 GB, go for 8 GB. Instead of 8 GB, go for 16 GB. Instead of 16 GB, go for 32 GB. So increasing the capacity of one system is called as vertical scaling. The process of increasing number of instances or number of servers is called as horizontal scaling. Auto scaling is the process of increasing or decreasing infrastructure or resources based on the demand. That auto scaling can be done in two ways. One is called horizontal scaling. Second one is called vertical scaling. Horizontal scaling means increasing the number of instances or number of systems or number of servers, I can say. Increasing number of instances or number of servers. Run your application in the multiple machines or run your application in the multiple pods. That is called horizontal scaling. Now here in the Kubernetes, we have horizontal pod auto scaling and vertical pod auto scaling. So in the Kubernetes, we are going to use horizontal pod auto scaling, that is called HPA. So what is this HPA? What is the horizontal pod auto scaler? Horizontal pod autoscaler, which will scale up or scale down the number of pod replicas based on the metrics that are observed. So horizontal pod autoscaler will scale up or will scale down number of pod replicas of deployment or replica set or replication controller dynamically based on the observed metrics, CPU or memory utilization. Now here if you see how this horizontal pod autoscaler is going to work. Now here I will install my application. I will deploy my application in the Kubernetes cluster. I will deploy my application in the Kubernetes cluster, and for that application, one pod will be available. For that application, one pod will be available. So what I want to do is, when more load is coming on the machine, if the worker node machine CPU utilization going above 50%, then I want to increase the pod count. If CPU utilization going above 50%, then I want to increase the pod count. Who will monitor our CPU utilization? That's where metric server comes into picture. So first I'm going to install metric server in my Kubernetes cluster. That metric server will monitor the top nodes, top pods. If any node going above 50%, that metric server will give the information to HPA. HPA stands for horizontal pod autoscaler. When the HPA receive the information from the metric server, HPA will check the condition. For the HPA, I will write the condition. If a CPU target percentage is above 50, then you increase my pod count. Then you scale up the pod count. If a CPU utilization is less than 50, then you scale down the pod count. So metric server will be installed. Metric server will check the metrics of our nodes and it will check the metrics of our pods. The metric server will give the information to HPA. HPA nothing but horizontal pod autoscaler. It is used to increase the pod count and decrease the pod count based on the demand. In the HPA, I will configure if a CPU utilization is going above the target value, I will give 50% as a target value. If it is going above 50%, then you need to increase the pod count. If it is less than 50%, then you need to decrease the pod count. This is called horizontal pod autoscaler in the Kubernetes. So it is very important question in the interview as well. What is the horizontal pod autoscaler in Kubernetes? First, what is autoscaling? Autoscaling is the process of increasing or decreasing the resources based on the demand. How it will work? When less number of requests are coming, one pod will be created to run my application. When more number of requests are coming, multiple pods will be created to run my application. This auto scaling can be done in two ways, HPA, VPA. We are learning HPA, horizontal pod auto scaling. Okay, guys. Now here, how this horizontal pod auto scaling is working. In the horizontal pod auto scaling, we are going to configure our metric. So I'm going to configure CPU utilization 50% target. If CPU utilization going above 50, then my scale up should happen. My pods should be created. Pod replicas should be created. If it is less than that, then we need to decrease the pod count. So here, how it will understand CPU percentage is above 50 or not. So to understand CPU percentage is above 50 or not, we are going to install metric server. Metric server will collect the data. Metric server will give to the HPA. Based on the threshold value, HPA will decide whether it has to create the new pod replicas, whether it has to delete the existing pod replicas. Now here, when you see that HPA, before HPA scaling, single pod will be available. After the HPA scaling, multiple pods will be created. Horizontal pod auto scaler. In order to implement this horizontal pod auto scaler, I'm going to follow these steps. I need to install my metric server first because metric server is required to capture metrics of our cluster. Once the metric server is installed, then I will deploy a sample application in the Kubernetes cluster with a single pod replica. I will deploy my application in one pod. Then to expose that application will create a service. Fine. Installing the metric server, deploying the application, creating the service. Then after, I need to deploy my HPA, horizontal pod autoscaler. Metric server will give the instructions to the horizontal pod autoscaler. Horizontal pod autoscaler will check the target percentage. If it reaches the target percentage, then it is going to create the new pods. Now here, how can I increase the load on the HPA? How can I increase the load on my application? To increase the load on the application, I will use load generator. So by using load generator, I will increase the load on that particular worker node. When the particular worker node load is increased, CPU utilization will go high. When the CPU utilization is high, HPA will recreate the new pods. Okay, guys. So let me set up this metric server and let me deploy this application and let me set up HPA. Yesterday, I have prepared the same video and I have uploaded. Many of the people did not watch that video. So whatever the topic that I am discussing, already I have posted that video in the YouTube yesterday night. What is horizontal pod autoscaler? How to set up that horizontal pod autoscaler in the Kubernetes cluster. Good. See here, I want to set up my metric server. To set up the metric server, I have given GitHub repository, guys. So in the GitHub repository, I have given the link to download the manifest files that are required to set up our metric server. Go to here. In my GitHub repository, you can check Kubernetes metric server. You need to download this GitHub repository, which is available in my account. Go to my GitHub account, check the Kubernetes metric server. There you can see deploy folder. In the deploy folder, 1.8 plus is available. I want to install that metric server. Before installing the metric server, first let us check that metric server is working or not. kubectl top nodes. Is it working? Currently, metric server is working in my machine or metric server is not working in my machine. Currently, metric server is not working in my machine. Now I need to install metric server in my machine. So to install that metric server, we need to clone this GitHub repository, guys. Kubernetes metric server repository is available. You can take my GitHub repository URL and you can clone it. I have already cloned that in my machine. So here, Kubernetes metric server is available. Let's go inside that directory, Kubernetes metric server. Inside that metric server, we are having deploy directory. Inside the deploy directory, we are having 1.8 directory. So if you go to this 1.8 directory, there are several manifest YMLs are available. Metric service, metric RBAC, metric server deployment, metric server service YML, metric server service account. Several manifest YMLs are available. We need to execute all these manifest YMLs. When we execute all these manifest YMLs, then metric server will be deployed in our Kubernetes cluster. What is the role of metric server in our Kubernetes cluster? What is the role of metric server in our Kubernetes cluster? Metric server is responsible to capture metrics of our cluster and give that as input for the HPA. HPA stands for horizontal pod autoscaler. Now go here. Let me execute all these YML files. kubectl apply -f dot. So with this, I'm executing my metric server. So whatever the configurations that are required to install the metric server, all those YML files I have executed by using kubectl command. kubectl apply -f space dot. With this, all these 5 YML files available, those 5 YML files got executed. When these 5 YML files got executed, metric server will be installed in our cluster. Once the metric server got installed, we can check top nodes command. Okay, guys, let us check this. kubectl top nodes. Are we able to get that? So earlier, when I execute that command, it has given error. Earlier, when I execute top nodes command, it has given error because at that time, my metric server not installed. At that time, metric server not installed. After installing the metric server, I'm executing kubectl top nodes command. I'm able to get the nodes which are running in my cluster and what is the CPU utilization of those nodes and what is the memory utilization of those nodes and what is the CPU utilization of those nodes I'm able to access. So here, one worker node is using 1% of CPU. Another worker node is using 2% of the CPU. Memory, 21% and 20% memory is available. So with this, I completed one step here. I installed metric server. Now, if I want to deploy sample application and I need to create a service and I need to deploy HPA. For that, I have uploaded manifest files into our GitHub repository. So same repository, guys, Kubernetes manifest YML files. I have created another directory in that repository that is 05HPA. So here log related directory available and now I created HPA related directory. In the HPA directory, here we have deployment.yml, we have service.yml, we have hpa.yml. Deployment.yml, it is used to deploy my application in the Kubernetes cluster. API version, kind is the deployment, name, labels, replicas. I'm giving one replica, pod template, and Docker image that I'm giving here. So here I'm taking a dummy Docker image for HPA example from the Kubernetes cluster. You can give our image name also. I'm using a predefined Docker image available in the Kubernetes. Here I'm configuring resource limits 500 MB, resource request CPU 200 MB. It has to use 200 MB memory from the CPU and maximum it should go to 500 MB. So resource limits, resource requests that we are configuring for our pod deployment. Resource limits 500, that means at max it should use only 500 MB memory of our machine. Request initially it should take 200 MB. If required, it can go up to 500 MB like that. We are configuring resource limits and resource requests in our deployment YML. Then to expose the deployment YML, I'm creating a service here, right? I'm mapping that to the port number 80. So just it is a service. In the service, I'm configuring selector. Pod label I'm giving in the service. I'm exposing that pods as a service. Now, next one, HPA is available. This is the most important. HPA, it is used to create horizontal pod autoscaler in our Kubernetes cluster. I want to create this horizontal pod autoscaler in the Kubernetes cluster. Here metric server is available. Now I am creating the HPA. So in the HPA, what we are configuring? In the HPA, we are configuring that horizontal pod autoscaler should be created. API version. Now, kind is the deployment. HPA demo deployment. So I am deploying my application with a name called HPA demo deployment. If you go to the deployment.yml, what is the deployment name I am giving? HPA demo deployment is the name I am giving. This name I am configuring in my horizontal pod autoscaler as a scale target reference. Now, minimum replica count I am giving as 1, max replica count I am giving as 10, target CPU utilization percentage I am giving as 50. So that means Whenever target CPU utilization reaches to 50%, then you scale the deployment. This is called auto scaling. This is called auto scaling. So minimum count I'm giving as 1, maximum count I'm giving as 10. I'm giving my deployment name. So here I'm deploying my application in the Kubernetes cluster. This deployment name I am configuring with the HPA, and in the HPA I'm giving target CPU utilization percentage 50. So what is the meaning of target CPU utilization percentage 50? If CPU utilization reaches to 50%, if CPU utilization reaches to 50%, then it has to scale the deployment. Earlier, in the replication controller and in the replication set, we have executed scale command. We increased pod count manually. We decreased pod count manually. If you see in our notes, when we created replication controller or replication set, we have increased the pod count by using scale command. kubectl scale replication controller, replicas 5, replicas 10, replicas 3. Like this, we have scaled our deployment manually. You see here, kubectl scale the deployment, Java web application deployment. With this name, I have deployed my application and I want to increase the pod replicas to 5 and I want to decrease the pod replicas to 3. This is manual scaling. Now I don't want to go for that manual scaling. I want to go for auto scaling. I want to go for auto scaling. So here, how this auto scaling is happening? Auto scaling is happening with the HPA. Auto scaling is happening with the HPA, that is horizontal pod auto scaler. Horizontal pod auto scaler. So what is the meaning of a horizontal pod auto scaler? When the CPU utilization reaches to 50, automatically my deployment should be scaled. For that, I'm using horizontal pod auto scaler. Okay. Now let me deploy my application and let me deploy that horizontal pod auto scaler. So as discussed in the GitHub repository, I have given that directory, right? ls-l. If you go to Kubernetes manifest YML files, if you go to Kubernetes manifest YML files, here you can see one directory called 05 HPA directory is available. So let me go inside that directory, 05 HPA directory. In this, there are 3 manifest YMLs are available. So these manifest YMLs, first one is used to deploy my application. Second one is used to expose the service. Third one is used for horizontal pod auto scaler to scale my deployment. Let me execute my deployment first. kubectl apply -f deployment.yml. With this, my deployment is created. Let's verify that deployment. kubectl get to deploy whatever we have deployed. Now you can see HPA demo deployment is completed. So one deployment is done, and in that deployment, one pod is created. You can check kubectl get pods. So currently for HPA demo deployment, how many pods are running? One pod is in the running state. 21 seconds ago, my pod got created. What is the status of the pod? Pod is in the running state. 1 out of 1. I want to create one pod. That one pod got created and that one pod is in the running state. So right, now I want to expose this pod by binding to a service. So kubectl apply -f 02 file is available, which is a service.yml. So with this, service got created for the deployment. Deployment created and service created. Let us verify that. kubectl get a service. Right. With this one, service is created. That service type is a headless service. That means no IP is available. It is a headless service. You cannot access that. Fine. Now verify kubectl get a deploy. So one deployment is available. In that, one pod is available. One service is available. One deployment is available. And get the pods. Now, one pod is running. Now I want to deploy my auto scaler, right? Metric server is installed. My deployment is also completed. One pod is running. So to scale this deployment, to scale up, to scale down my deployment means pods created. To scale up, to scale down the pod count available in the deployment, I need to deploy the horizontal pod autoscaler. For the horizontal pod autoscaler, I need to tell which deployment it has to scale up or scale down based on what threshold it has to scale up or scale down. That configuration is available in the HPA.yml. So here I'm giving target reference. It has to scale up or scale down the deployment which is having this name. And what is the minimum count? Minimum count is 1, maximum count is 10. What is the threshold? The threshold percentage is CPU utilization 50. If a CPU utilization reaches to 50%, then it has to increase my pod count. If the CPU utilization is less than 50, it has to decrease my pod count. So let me create that HPA kubectl apply -f 03 HPA.yml. So with this, my horizontal pod autoscaler got created. Let us verify that horizontal pod autoscaler get a HPA. When I get the HPA, so HPA deployment is there. Deployment name is HPA deployment. My pod autoscaler is associated with the deployment name which I have created. Minimum pod count is 1 I have given. Maximum pod count I have given 10. Just now my HPA got created. For this HPA, what is the target percent I have given? For the HPA I have given target percentage 50. What is the current percentage? Current percentage is unknown. Let me take a duplicate tab here to show you that. Not detaching the tab. Let me connect back to this. kubectl get pods. One pod is running, guys. kubectl get a HPA. My HPA is also created. kubectl get a deployment. My deployment is created. So whatever the deployment is created, that deployment name I have given as a reference for the HPA. And a target percentage I have given 50. Minimum pod count I have given 1. Maximum pod count I have given 10. Replica count is currently 1 replica is available. Okay, guys. Now let me take the duplicate tab. Yeah. So if I go to the duplicate tab, let us take the get HPA, kubectl get HPA. Currently, how many pod replicas are available in the auto scaling, guys? In my deployment currently, how many pods are available? Observe carefully. Next 5 minutes is very important. Pod replica count is 1. What is the target percentage I have given? The target percentage I have given as 50. What is the current percentage? The current percentage is 0. So is there any load on our machine? Anybody accessing our application? Guys, anybody accessing our application? Nobody accessing our application now? I want you people to respond in the chat. Anybody accessing our application, or people are not accessing our application? Anybody accessing our application, or nobody accessing our application? People are not responding. Nobody accessing our application. So that's why, what is the current CPU utilization, guys? The current CPU utilization is 0. What is the target utilization I have given? 50. So if you see this deployment YML, horizontal pod autoscaler, what I have given here, target CPU utilization percentage I have given as 50. So that means when CPU utilization reaches to 50%, it has to scale my deployment. Which deployment it has to scale? I have given the deployment name. So here I have deployed my application in the cluster. For that I have given a name. That name I have given as a reference for the scaling purpose. So when CPU utilization reaches to 50, it has to scale the deployment. It has to increase the pod count. Minimum pod count is 1. Maximum pod count should be 10. If it is greater than 50, pod replicas should be increased. If it is less than 50, pod replicas should be reduced. That is called auto scaling. Now go here, check your HPA, horizontal pod autoscaler. What is the current target percentage? Still it is 0. What is the expected percentage? 50. If it reaches to 50, my replicas should be increased. Currently, how many pod replicas available? Guys, currently, how many pod replicas available? Only one pod replica is available. Why there is only one pod replica? Why there is only one pod replica? There is no load on our machine. There is no load on our machine. You can see here, kubectl get pods. Still there is only one pod is running. Same command you can execute here also. Kubectl get pods. Kubectl get pods. Currently only one pod is running. That pod is in the running state. You can go for kubectl HPA events. Kubectl HPA events. Kubectl get HPA events. Horizontal pod autoscaler events not found. Okay, good. Now I want to increase the load on this machine, guys. I want to increase the load on my machine. To increase the load on the machine, I'm going to use load generator. By using one command, we can increase load on our machine. That is load generator. So this command I am going to use to increase the load. Now my HPA demo deployment is available. I want to increase the load on my HPA demo deployment by using this URL. That is my service name that I have given, HPA demo deployment. Take this command and execute this command. So this command is going to increase the load on my deployment. kubectl run tty load generator by using busybox. By using busybox, I want to generate some load. By using busybox, I want to generate some load on that deployment. Now see here, the load will be generated on that. Now see here, okay. That means it is keep on stressing my deployment. It is keep on accessing my deployment. So the load is increasing. When the load is increasing, let us check our HPA, kubectl get HPA. Now you see, still it is 0% currently. That slowly the load will increase on my machine because continuously I'm increasing the load on my deployment. That means I'm accessing my pods continuously by using this load generator. When the load is increasing, let us see what is our CPU utilization here. Get HPA. Now can you see? Earlier it was 0%. Now it increased to 198%. But what is our target? Our target percentage should be 50. If it is reaching more than 50, then pod replicas should be increased. Now let us verify. Get HPA. Now you see, so the utilization is going beyond 50. Earlier it was 0. My pod replica count is only 1. Now as the load is increasing on that deployment, pod replica count also increased to 4. Earlier 0% available. I have executed one command to increase the load on the deployment. When the load is increased, the CPU utilization is reaching the given threshold value. When the CPU utilization reached given threshold value, automatically it increased my pod count. Now you can check the pods which are running here. kubectl get pods. Earlier we had only one pod. Now what happened? Only one pod is available. The pods are keep on increasing. Auto scaling is happening or not happening? Guys, auto scaling is happening or auto scaling is not happening? Auto scaling is happening. How can we say that auto scaling is happening? How can we say that auto scaling is happening? You can see pod replica count got increased and the number of pods also increased. Now let's go and check it. Get HPA once again. kubectl get HPA. Earlier 4 pods available. Now how many pods are there? 8 pods available. So initially it was having only 1 pod. Then it increased it to 4. Now it increased it to 8. Now it increased it to 8. Now check it. The load is also keep on increasing and decreasing. The load is also keep on increasing and decreasing. Now pod count coming as 8. Now get HPA. So the pod count is 8. So 44% CPU getting utilized now. Threshold value is 50. When the load is reducing, pod replicas also will reduce. When the load is increasing, pod replicas also will reduce. Okay. kubectl get HPA events. kubectl get HPA events. kubectl get events. Now you can see the events available. Load generator is available, pulling the busy box image, scaled up the replica set, new size, CPU resource utilization, scaled up, new size 4, created the pod. What happened internally, we can see that. Successfully assigned the default HPA demo, pulling that image, created the container, pulling the image, creating the container, pulling the image, creating the container. So here, when the load is increasing, our pods are increasing. So we can get that by using kubectl get events. What happened in our cluster, we can see all those events by using kubectl get events command. Go to kubectl get HPA. Now you can see the percentage of CPU 44% it is utilizing and replica count is 8. So minimum 1, maximum 10. If you want maximum 20 pods, then you need to increase max replica count to 20. Then whatever the value, what is your upper limit that you can configure in the autoscaler. Now, continuously the load is generating on the deployment. If you want to stop that load, then press Ctrl C. When you press Ctrl C, the load will be stopped. Now, I have terminated my load generator. Load generator also executing as a pod only. So by using this command, I'm able to generate the load. It is using one image called busy box image, and it will keep my machine busy by accessing that deployment which we have created. This is the deployment name that I have given here. With the deployment name, it is going to increase the load on the deployment. When the load is increasing on the deployment, autoscaler is going to increase the pod count. Now I have stopped my load generator. Once I stop the load generator, the load will be reduced on the deployment. When the load is reduced on the deployment, pod count should be decreased. Now get HPA. Earlier 44% is available. Now it came to 0%. So because I have stopped my load generation. So here I have given a command which is used to increase the load. So once you increase the load, HPA is going to check the threshold value. So here, once the threshold value matches, it will scale up the pods. Once the threshold value is not reaching, it will scale down the pods. Metric server is available. Metric server will get the metrics, will give to HPA. HPA will check the value. If it is meeting that value, then increase the pods, otherwise decrease the pods. Now go back and check this. kubectl get HPA. Percentage is 0. Still pod replicas are 8. Slowly it will reduce the pod replica count also. Get HPA-W. So get HPA-W. When I give get HPA-W, for every 15 seconds, it will print the metrics of our autoscaler, how it is doing that. So let's wait. I executed a command kubectl get HPA with -W. It is showing the statistics of our horizontal pod autoscaler. Horizontal pod autoscaler is used to scale up and scale down our pods based on the demand. So in the autoscaler, I have configured CPU utilization percentage as 50. If my CPU utilization reaches to 50 for that deployment, then it will increase the pod count. Otherwise, it will decrease the pod count. Now, let's wait for this. Pod replica count is still 8. Load is reduced. Load is not there. Then slowly, immediately it is not going to make it as 0, guys. Slowly it will decrease to 7, 6, 5, 4, 3, 2, 1, 0. Like that. Step by step, it is going to decrease the number of pod replicas available in the deployment. Here you can check this in the another tab. kubectl get pods. The pods are still in the running status. kubectl get HPA. Now here you can see still the 8 replicas are available. Slowly it will reduce. Yesterday, it took 5 to 10 minutes of time to reduce the pod count, guys. After load generator got stopped, it took 5 to 10 minutes of time to reduce the pod count. Increasing happening quickly, but reducing the pods count happening slowly. HPA events, it is not showing here. Still 8 pod replicas are available. Let's wait few more minutes. I want to show you that down count also. Why is it like that? That is the behavior of autoscaler. When the load is increasing, immediately it will create the new pods. When the load is reducing, slowly it will decrease the pod count. That is the default behavior of autoscaler. When the load is increasing, pod counts will be increased immediately. When the load is reducing, slowly it will reduce the pod count. Still 8 pods are running. Even though there is no load, slowly it will come down. Automatically, it will increase the pods and it will decrease the pods based on the demand. I'm waiting. At least one pod should be deleted automatically. Yeah, you can see here, second event triggered here, but the second time also, the replica count is not reduced. I think for every 1 minute, it is printing. Yeah, now you can see replica count reduced to 7. Now guys, so if you are executing kubectl get a HPA with -w, for every 15 seconds or for every 30 seconds, it is printing. Now slowly the pods count is reducing. Can you see that? Slowly the pods count is reducing now. 8 pods available. It came to 7. Now it came to 5. One more event will be printed. Yes. Now, what is the pod count now? What is the pod count now? 1. It is reducing. Why it is reducing the pod count? Why it is deleting the pods? Why it is deleting the pods? Because there is no load on that. Because there is no load on that. Can we increase? Can we increase the load now? Again, can I generate the load on that? Again, can I generate a load on that? Yes. How to generate the load? Load generator command is available. By using load generator, we can generate that load. Let me copy that command. So here, this is the deployment name. On this deployment, I am generating the load. Copy this command and execute. So again, load will increase on the deployment. Yes, load is increasing on the deployment. When the load is increasing on the deployment, let us see the behavior of autoscaler. Pod count came to 1. Now let us see what will happen. Load is increasing. Now you see, the moment I executed the load generator, the value got changed or not? It reached it to 73% again. It came to 0. Again, I generated the load. Then it is going to 73%. When it is 73%, can you see pod count is increased? Increasing the pod count is happening very quickly, but decreasing the pod count is happening slowly. Auto scaling. Practically, we are able to see what is auto scaling, how it is working. Now you see the count is becoming 4. From 8, it came to 1. From 1, it went to 2. Now it is 4. Yes, it became 6. Maximum at what level it can go? Maximum at what level it can go? 10. Because I have given count as 10. Now see, pod count slowly reduced and slowly increasing. So with this, can I say Kubernetes supports auto scaling? With this, can I say Kubernetes supports auto scaling? Yes. What is the meaning of auto scaling? Guys, what is the meaning of auto scaling in the Kubernetes? Increasing the pods and decreasing the pods based on the demand. That is called auto scaling. Okay. Shall I stop my load generator now? Shall I stop my load generator? Control C. Stop it. Load generator got stopped. When the load generator got stopped, now check it. The behavior of the autoscaler. Now load is slowly reducing. When the load is reducing, pod replica count should be reduced. Now load came to 6%. Slowly it will go to 0. When it is 0, slowly pod count will be reduced. Automatically it is increasing and it is decreasing. Yeah. Finally it came to 0%. I'm waiting for one more event. As I told you, pod replica count increasing is happening immediately, but decreasing is taking time. Right? Here load got stopped. kubectl get HPA. Still 8 pods are there. Even though load is 0, the reduce will happen slowly. Okay, good. Auto scaling, this you can do for database also, you can do for your application also, because whichever the deployment that you do, that deployment can be configured with the auto scaler. Just you need to give your deployment name and your threshold value. That's it. Good. Perfect. So with this, we understood what is auto scaling in the Kubernetes and how to configure horizontal pod auto scaler. Similarly, vertical auto scaling, nothing but the energy that should be increased for our machine. We don't do that, guys. We can't perform that vertical auto scaling. Generally, auto scaling can be done horizontal and vertical. In the AWS, auto scaling is available. So when it comes to the AWS classes, we are going to understand how to do vertical auto scaling. So in the AWS, auto scaling group is available. Load balancers are available. What is horizontal scaling and how to do vertical scaling in the AWS cloud, that we will discuss in the AWS classes. EC2 service is available. In the EC2 service, auto scaling load balancer concept is there. At that time, I will explain what is vertical scaling. In the Kubernetes, For the pods, we will go for horizontal pod autoscaler. Good. Fine. Get HPA. You see, still 8 pods are available. It is not deleted any pod as of now. Slowly the deletion has started. From 8, it came to 7 now. So slowly it will delete the pods now because the load is 0. There is no load on the deployment. Slowly it is deleting our pod replicas. Yes. From 8, it came to 7. Yes. So I think you got the clarity. What is auto scaling? How to configure auto scaling in the Kubernetes. Let me stop out this. Done. Let's quickly revise what we discussed. What is horizontal pod autoscaler in the Kubernetes? So here, autoscaling means it is the approach to automatically scale up or scale down the number of resources that are allocated to our application based on the demand. When less number of users are accessing, less load will be available. When there is a less load, less number of pods will run to execute my application. When more number of users are accessing, more load will be there on our system, then more number of pods should be created to handle that, the user requests. So here, how this autoscaler is working. We have installed metric server installed in our cluster that will check the metrics of our machine. What is the CPU utilization? What is the memory utilization? That information we can get from metric server. Okay, guys. Then I have installed my application in the cluster. I have deployed my application in the cluster. For that, there is a deployment name. After my application deployment got completed and I exposed that application by using a service. Then finally, I have deployed horizontal pod autoscaler. For the horizontal pod autoscaler, I have given my deployment name. For horizontal pod autoscaler, I have given my deployment name. For the horizontal pod autoscaler, I have given the deployment name and I have given the threshold value. CPU utilization 50. If CPU utilization reaches to 50, it has to scale up my deployment. That means it has to increase my pod count. Minimum pod count I have given as 1. Maximum pod count I have given as 10. So in general, nobody accessing this application running in the cluster. That's why I'm creating the load by using load generator. I have increased that load. When the load increased, pods count got increased. When load decreased, pod count got decreased. So here, before scaling, 1 pod is available. After scaling, we got 4 pods, 6 pods, and 8 pods also. So what are the steps I followed to do that? I have installed metric server in my cluster. For that, YML files I have executed. Those files available in the Git repository. Then I have deployed my sample application and I exposed that application as a service. Manifest YMLs I have given. Then I have deployed horizontal pod autoscaler. After that, I have increased load on my deployment. After increasing the load on the deployment, I monitored HPA events by using kubectl get HPA-w. With this, I'm able to monitor my HPA events and what is the count that is there. I'm able to get that. Now you see, when I execute this command once again, pod count is 1. That means it deleted all the pod replicas which got increased when the load is increased. When the load is increased, pod count will increase. When the load is decreased, pod count will decrease. This is called horizontal pod autoscaler in the Kubernetes. Clear? Clear with all of you? Here we are doing only pod replications, not node replications. Node replications we will do in the AWS. So here, node replication means already when the cluster is created, minimum nodes I have given 2, maximum nodes we have given 5. When any one of the node is deleted, automatically one more node will be created. That is called node scaling. In the Kubernetes, so whenever we create the EKS cluster, 2 worker nodes are associated with that. If you delete any worker node, automatically another worker node will be created. That is called node scaling. Currently, we have seen pod scaling. Both are different. Node scaling is different. Pod scaling is different. Pod scaling will not happen automatically. We need to configure pod autoscaler. Node autoscaling will happen automatically in the EKS. Suppose now I have this machine. If I delete this machine from here, action, instance state, if I terminate this instance, what will happen? One more instance will be created. Let me show you. So there are total 3 machines are available. EC2 dashboard, if you see here, there are total 3 instances are running in my cluster. What are those 3 instances? One is my EKS client VM. One is my EKS client VM. So this is worker node 1 and this is worker node 2. Suppose, for example, I'm deleting one worker node. Instance state, terminate that instance. Click on terminate. That instance I have terminated. Now see, automatically one more instance will be created or not? If it is created automatically, that is the power of the Kubernetes cluster. Self-healing capacity is available for the Kubernetes cluster. When any particular node is down, Kubernetes will replace that with the another node. Now, I have terminated one instance here. Let us check this. When I terminate that instance, what is happening in the cluster? Currently, 2 instances are running. Currently, 2 instances are running. One is my client VM, another one is worker node. Actually, I should have 2 worker nodes. I have deleted one worker node now. Let us see what will happen. What our cluster will do. Let's give some time for that. The Kubernetes dashboard. Currently instances running are 2. Go to the instances count. I have terminated one worker node from that. Only one worker node is currently running and my client VM is there. One worker node is running. I have deleted another worker node. Now, let us check this. Still, it is not launched that. Let's give some time. I'm refreshing this page to see the new worker node which is coming up. It should come up. Did anybody try this, deleting the worker nodes? Did anybody try deleting the worker node? Yes, automatically created. Yes. So people are already saying that, yeah, now see, instances running count became 3. Earlier it should be 2. Earlier it should be 2. Now see here, one more worker node got created. See here, it is in the initializing state. It is in the initializing state. It created today. Actual my machines created on 3/31, March 31. This is April 12th. This machine is started just now. It is initializing T2 medium. So when one instance is deleted, do I need to create the another instance or Kubernetes will do that automatically? Kubernetes will do that automatically. This is the proof. I have deleted, there are 2 worker nodes earlier. I have deleted one worker node. Automatically, I got another worker node. That is called self-healing capability in the Kubernetes. This is vertical scale. This is also horizontal scaling only, right? When one instance is deleted, another instance is getting created. So node scaling is happening by default in the EKS cluster. Pod scaling will not happen automatically. We have to do this. Pod auto scaling will not happen by default. We need to configure horizontal pod auto scaler. But node auto scaling will happen automatically. When one node is deleted, automatically another node will be created. That is the power of EKS cluster. Now, if you go to this EKS cluster and if you execute kubectl get nodes. Now, so there are 2 worker nodes available. One worker node created 12 days ago. Another worker node created 69 seconds ago. So earlier we had 2 worker nodes. From the 2 worker nodes, I have deleted one worker node. One more worker node got attached to the cluster. So I'm doing this attachment to the cluster or cluster itself creating that node when one node got damaged. When one node got damaged, automatically it created another node. But will it happen with the pods automatically? No, with the pods, it will not happen automatically. For the pods, we need to configure autoscaler. Okay, guys. So how to configure this autoscaler? I have given the steps clearly here. What is autoscaling? What is autoscaling? And how to check this metrics server is available or not, and how to install the metrics API. I have given my GitHub repository URL to clone this metrics API files and install them. Once it is done, deploy the sample application. This is my application URL. You no need to take it from here. I have already given in the Git repository. You can clone that. For that, I am creating a service. Okay. Then after that, creating the HPA. For the HPA, we are giving this YML. Once it is done, you can get the HPA. You will see only one pod replica will be available. After that, we are going to increase the load by using this load generator. Then we can monitor the HPA pods. So after executing this load, take the new tab. After executing load generator, open duplicated tab to monitor HPA events. After, how to take the duplicate tab? Here, right click on this duplicate tab. So say another tab will open. In that tab, you can execute the command. In one tab, load will be increasing. In another tab, you can monitor your events. After executing load generator, open duplicate tab and monitor the HPA events. So you can describe the deployment, you can get the events, and you can see what are the top pods, what are the get HPA is available. Once it is done, I'm going to delete everything. kubectl delete all all. Okay. So after this, we can delete the metric server also by using the deployment name. Good. So with this, we are able to understand horizontal pod autoscaler. Thank you, guys.